All right, let's take a look at this first example for Hess's law. As I told you earlier, for these questions, you're always going to be given a target equation, and you have to figure out the delta H of this particular target equation. And you're also going to be given some reference equations. In this case, I'm given 3. And for the reference equation, I always know what the delta H values are going to be. Right, so let's get into this particular question. I just wrote this again so that I can have a little bit more room to show my work. So what I want to do is I want to go through each of those reference equations and compare it with my target equation. Right, so I have here carbon plus oxygen gives carbon dioxide. I want to compare which things I have in common with the target equation, and if the coefficient is correct, and if it's on the right side of the equation. So the only thing I have in common is the carbon, right? And I'm going to check for the coefficient first, so it has the same coefficient, and for both of these equations, it's on the reactant side. So I'm pretty happy with that. So I'm not going to change anything about this reaction. I'm just going to call that, I'm going to write multiplied by 1, right? I'm going to keep that the same. For question number 2, the only thing that I see that is in common is the carbon monoxide, so the CO. The only difference, so it has the same coefficient, but in my target equation, it's on the product side. And on the reference one, it's on the reactant side. So I think it would help if I flip this reaction. And when I flip this reaction, I'm going to multiply it by -1, right? Remember our rules that we learned about making changes to those equations. So I'm going to write that as a -1, just so that I can remember when I look back that I meant that I want to flip this equation. Now for the third one, I see H2 here. And I see that here. So you'll notice, again, it's on opposite sides. So this is on the reactant side, and this is on the product side. I also have H2O gas here, which again is on the opposite side. So in the reference reaction, it's on the product side. In the target equation, it's on the reactant side. So what I want to do is I want to multiply that by -1. So if I flip that, I think both of those would work out, right? Because they're both on opposite sides in the target equation. What I want to do next is, before I get into the numbers, I want to see if I made these changes and if that actually does give me the target equation, right? Only then can I move on to adding up those numbers in the appropriate manner. So I'm going to rewrite these equations with the changes that I said that I wanted to make, right? So the first one, I decided to keep that exactly how it is. Again, this is because I compared it to my target equation and I noticed that the coefficient was the same for the carbon, as well as it was on the correct side of the arrow. So they were both reactants in both of those reactions. So in my second equation, I said I wanted to flip it over. So my carbon dioxide becomes my reactant, and my carbon monoxide, as well as the 1/2 of O2, becomes my product. And for the third one, I was going to flip that one as well. So H2O gas is going to be on my reactant side. H2 is going to be on my product side, plus the 1/2 of O2 is on the product side as well. So this is my reaction. These are my reactions after the changes have been made. So reference reactions 1, 2, and 3. What I'm going to do is combine these, right? And instead of writing out all of these things, I think I can cancel out a few before I even combine them. That might make my life a lot easier, right? And in order to do that, I'm just going to compare anything that I see on the right side of the arrow and anything that I see on the left side of the arrow. If they're the same, I'm going to cancel those out, right? So CO2 gas, I see one CO2 gas, another CO2 gas. They're both on opposite sides, going to cancel that out. Now here, I've got 1/2 of O2 here, and another 1/2 of O2 here. 1/2 plus 1/2 gives me 1 O2. If you'll notice, I've got 1 O2 here. So these two together will cancel out that 1 O2. Now my equation, I think that's all that I can cancel out. Let me just combine them after that. So C plus H2O. Now the symbols, so the states are important. For this case, for all of the equations, I would recommend that you write the states every time. So carbon monoxide is the product plus H2 is the other product. Now comparing this equation to my target equation, it is exactly the same. So I know that this is the correct setup. So what I'm going to do is apply these changes to the delta H values and then add it up to find the delta H of the target equation. So for the first reference equation, I kept the equation the same. So I'm going to keep the delta H the same. So 393 kilojoules per mole. For the second one, I flipped it over. So because I flipped over that equation, I'm going to change the sign of the delta H to be positive 283 kilojoules per mole. For the third one, again, I flipped that one over. So instead of it being negative 242, it's going to be positive 242 kilojoules per mole. I'm going to sort of show those symbols here just so that it's obvious. And because all of these equations added up to give me that target equation, I can add up all these delta H values to give me the delta H of this reaction. And the answer is positive 132 kilojoules per mole.